Hello! Now we're going to be continuing our study of how to apply the law of sines to a non-right triangle. Now let's get this given situation out. This case is going to be called the ambiguous case, also what I like to call the ASS case, the ass case, because you're given an angle, a side, and a side. So right that you can note that once you get the ass case, just like how it's funny to say that word, you realize that it's not a good thing for your mathematics, because you're going to have to jump through a mathematical loophole, and we'll discuss what I mean by that here in a second. So let me first highlight these values here. So we are given an angle 43 degrees here for A, and two sides. Little b is 62 and little a is 81, but we don't know what little c is. That's a question mark. And we don't know what capital B is, and we don't know what capital C is, okay? And so that whole trick where we get to just add up the angles that we were given and subtract that from 180 to get the unknown final last angle, that trick doesn't work here because we don't know 2 out of the 3 angles. So now we're going to have to work around that. But we are still given the law of sines is as follows. You know, it's A divided by sine of capital A. Which is equal to little b divided by sine of capital B, which is equal to little c divided by sine of capital C. Okay, that is our law of sines. Now, let us plug in the information that we're given into the law of sines. So we know A is 81, so this is 81 divided by sine of A, which is sine of 43 degrees. That's equivalent to little b, which is 62, divided by sine of capital B, we don't know it yet, and that's equal to little c, unknown, all divided by sine of capital C, we don't know it yet. So notice that we clearly know this ratio, and there's 2 unknowns in this expression, but one unknown in this expression. That behooves us to set this expression equal to that, because if we have one unknown, we can algebraically solve for the unknown, namely the sine of b term. So whenever we do that, I get 81 over sine of 43 degrees, which when you plug it into your calculator is just a number, is equal to 62 divided by sine of b. Alright, I multiply both sides by sine of b, getting 81 sine of b divided by sine of 43 is equal to 62. Then I'll divide both sides by the reciprocal of 81 over sine of 43, which gives me sine of 43 all over 81. Whenever we do this, we result in the following. We get sine of capital B is equivalent to 62 sine of 43 all over 81. Okay, so we have algebraically solved for sine of b, but notice sine of b doesn't really tell us what we're looking for. We're looking for b, not sine of b. So how do we find it? Well, as you guys know, we can take the sine inverse of both sides of this equation, okay, which gives me that b is equivalent to the sine inverse of 62 sine of 43 all over 81. Alright? Let you take a look at that here. Where you want to know what this is equal to. And so I'm going to clear up some real estate. Getting a little claustrophobic in here. Alright? And so we'll clear up some board space so that we can continue our quest to solving this problem. Whenever you plug in what sine of 43 degrees is, multiply times 62 divided by 81, and then take the sine inverse of that, your calculator will output a special value, okay? It'll output one of these values, so it actually will, because your calculator is only has so much brains, it only knows, as they say in the computer engineering world, as they teach people who are becoming software engineers, that the computer does what you tell it to do. It doesn't do what you mean it to do, or what you want it to do. It does what you tell it to do. And whenever you compute the sine inverse of this value, it only outputs one answer, namely 31 degrees. Okay? But that's not the only answer, because there's two answers for a sine inverse of this. So recall, for instance, here's an example. If we had sine of theta equal root 2 over 2, and I took the sine inverse of both sides, I would get theta is equal to the sine inverse of root 2 over 2. But notice that that means theta is not just pi over 4, right? That means theta is not just pi over 4. Not only is it not just pi over 4, it's pi over 4 plus a 2n pi, because that's the period of the sine function. Furthermore, it is also equal to pi over 4 plus pi plus 2n pi, which is really 5 pi over 4. Oh, actually, I need to correct this 1 second. So, pi over 4 definitely, the sine of pi over 4 is root 2 over 2. But let's look at the unit circle. Over here at pi over 4, that's one of our angles. The sine outputs, sine of pi over 4 is root 2 over 2. But notice that sine assumes positive values in the first and second quadrant. And so there is going to be another root 2 over 2 for sine over here. And actually it's going to be equivalent to pi minus pi over 4. So I added them, and I should have subtracted them. This gives me 4 pi minus a pi all over 4. This gives me 3 pi all over 4. So this goes right here. So our two answers are pi over 4 and 3 pi over 4. Okay, so theta is equal to 3 pi all over 4 plus 2n pi. All of this to say that this answer, 31 degrees, is not the only answer. You also need to get 31 degrees and find its difference with 180 degrees, okay? And I'll explain that as well. So all of this that I explained right now, earlier, is to show you that there's two outputs for the sine inverse. Now I'm going to show you why we have to take 180 degrees minus 31 degrees to get the other value of the sine inverse. Okay? Which, when you do that subtraction, this equals 149 degrees. Why are we doing this part? Well, remember the supplementary identity, that the sine of theta is the same thing as the sine of 180 degrees minus theta. We proved this in an earlier video. And so because of that fact, the sine of 62 times sine, so whenever I take the sine of both sides of here, because this has a sine inverse, I would get, for instance, the sine of b is equal to just 62 sine of 43 all over 81. Alright, just like this, it's highlighting that. But that would be the same thing, the sine of b, capital B, also equals the sine of 180 degrees minus this capital B, by this cofunction identity where b is taking the role of theta. So because of that fact, when we do it right here, we can also generate another angle whose sine inverse is the same thing numerically for b. And so we must look at which of these angles makes logical sense. Does 31 degrees make sense, or does 149 degrees make sense? This is why the ASS case is called the ambiguous case, because there's inherent ambiguity as to which angle you should pick. Because the sine inverse outputs two different values. It can be 31 degrees or 149 degrees whenever you input this parameter inside the sine inverse function. So you and I must determine which one is valid. So now, not only have I shown you why there's two outputs for a sine inverse, I now have shown you why we have to say 180 minus the first output. Now, let us determine which output is logical. To do so, we think in a rigorous logical mathematical sense. Okay, what do I mean by that? Well, I mean, to do this, you must assume it's one of them and see if there's a contradiction. If there is a contradiction, then that means your first assumption was false. So let's assume 149 is what B is. So, case number 1. Assume B is equal to 149 degrees. This leads to a contradiction. And this symbol means contradiction in mathematics. What is a contradiction, you ask? Well, the sum of the internal angles of a Euclidean triangle should add up to 180 degrees. But notice that A plus B plus C, which is equal to 43 degrees plus 149 degrees plus some C it should equal 180, right? But notice that 43 plus 149, whenever I add them, take a look here, I'll explicitly add them. Alright, that becomes a 12, put this over here, 5, that becomes a 9, carry the 1. It adds up to be 192 degrees even before adding the C. So C must be a negative angle for it to end up adding up to 180, and that's impossible. Okay, we don't have negative angles in this situation. And so our assumption of case 1, that B was equal to 149 degrees, is a flawed assumption. Okay, so we take that out. And so this is data that we throw out because it is not possible for our current triangle. So it must be 31 degrees. And so I'll delete this information and we'll examine what the case 2 says. Case 2 is that B is equal to 31 degrees, okay? B is equal to 31 degrees. All right, so then A plus B plus C should equal 180 degrees. Oh, but A is 43 degrees. Plus B, we're assuming, is 31 degrees. Plus C should equal 180, right? Oh, so, but now when I add 43 to 31, I get to 74 plus C is equal to 180. And so I get C is equal to 180 minus 74, okay? So that implies C is equal to, what do we have here, 106 maybe? I just did that in my head and I'm terrible at mental arithmetic, but that is actually correct. 106 is the value for C. Okay, so we now know what C is, it's no longer unknown. C is 106 degrees. And B, we have solved, is 31 degrees. So B is no longer an unknown. C is no longer an unknown. Okay? So the only thing left to solve for is little c. The leg length of little c. Let's continue to solve for it. So I will erase what we have here and proceed with the solution to this problem. As you know, you may ask questions in the comments or email me if you have any questions about any of the steps that I'm doing so far. So now, setting up the law of sines, I have little a over sine of capital A is equal to little b over sine of capital B, which is equal to little c over sine of capital C. Alright, so now numerically replacing these values with the symbols, I get 81 over sine of 43, which is equal to 62 divided by sine of 31, which is equal to, I don't know. We don't know little c, so we just leave it a little c divided by sine of 106. And so we could use either this instead of equal to this expression or this instead of equal to this expression. Either way, we will be able to set ourselves up to algebraically solve for little c and complete the problem here. We've already jumped through the most difficult hurdle, and that's determining which angle was the appropriate angle for capital B. So I'll just pick the one that's the most adjacent to it. All I gotta do is multiply both sides by a sine of 106. Then that implies I get little c is equal to 62 sine of 106 divided by sine of 31. And whenever you plug that into your handy dandy calculator and you compute it, you get that the output for little c ends up becoming approximately 114.2. And so this is what little c is. And so we've completed it. It's no longer a question as to what little c's numerical value is. It is 114.2. So we found little c, we found capital B, and we found capital C. And thus, we have completed our problem, and we have solved the ambiguous case. So no, whenever you have an AS case, you must check the two sign inverse values for their logical outputs.